The statement of the problem was to identify the concentrations of the sucrose solutions. The different colors were green, red, purple, blue, and yellow.
Hypothesis. If the solution has a lower concentration of sucrose, then the water will move to a higher concentration, thereby the water levels will increase. Materials. 1 potato cut into 6 pieces, 5 sucrose solutions, each being 250 milliliters, 250 milliliters of distilled water, 1 thermometer, 6.
Procedure. Obtain 5 sucrose solutions of varying colors, get distilled water, get 1 potato, chop the potato into 6 pieces, put each piece of potato in a beaker of sucrose solution, allow the water to stay overnight. Record the differences in temperature and water level.
This is the results of our experiment. The initial volume for all the solutions was 250 milliliters. The final volume for the red solution was 240 milliliters, while for the blue solution it was 255 milliliters, and for distilled water it was 265 milliliters. This is a comparison between Burke's group. They actually weighed the potatoes instead of actually measuring the amount of water that remained. So the initial weight of their potatoes before placing them into each solution, for the blue solution it was 2.3 grams, for the red solution it was 1.9 grams, for the yellow solution it was 2.4 grams, for the purple solution it was 2.4 grams, for the green solution it was 1.8 grams, for distilled water it was 2.3 grams. So this next value is after the potatoes have been sitting inside of the water. It was at for the blue solution it was at 2.6 grams. For the red solution it was at 1.8 grams. For the yellow solution it was at 2.2 grams. For the purple solution it was at 2.8 grams. For the green solution it was at 1.4 grams, and for the distilled water it was at 2.8 grams. This is a conclusion to our lab report. Our hypothesis is actually quite wrong, as water moving from a low to a high concentration does not cause an increase, it actually causes it to decrease, because it would actually cause the potato to expand due to the amount of solids being more inside of the potato, allowing for less water to escape and more water to come inside of the potato. So the actual comparison of our results actually seemed to be that red had the least amount of sucrose solution, green, purple, and yellow seem to have an average amount, and the blue seem to have the highest. But this is actually quite different compared to the molar concentration. Blue had 0.2, yellow actually had 0.4, red had 0.6, and green had 0.8, while purple was just 0, which is distilled water. Now we think that our results probably got skewed due to the size of the potatoes, which is actually one type of error. Some other errors we kind of noticed was the evaporation of the water, not checking the initial temperature, not weighing the potatoes, and not being able to carry out the experiment over 2 or 3 days. We are now figuring out whether each solution is either hypertonic, isotonic, or hypotonic. Based on our results, it seems that the blue solution is actually hypertonic, as it actually causes less water to enter the potato and more water to escape, thus increasing the amount of water and leaving a larger amount of solutes on the outside. The green, purple, and yellow seem to be isotonic, as they actually showed no change in the amount of solutes and the amount of water. Red seemed to be hypotonic, as it actually decreased the amount of water in solution, causing the potato to actually expand, allowing for less water to escape and more water to enter the potato. Now we are going to be finding the water potential of each solution. So basically we're going to have to multiply the ionization constant, molar concentration, pressure constant, and temperature. So the water potential of each varying color is, first beginning with blue, is a 4.87, yellow is negative 9.77, red is negative 14.61, green is negative 19.55, and P is 0, as it is actually distilled water. Thank you for watching our lab presentation, and I hope we get a great grade on it. Thank you.